Now, in a previous section, we talked about measures of center, the mean, the median, and the mode. And you can kind of see that reflected in these two histograms that we see here on this page, where because they're both symmetrical, the mean, median, and mode are going to be the same value, going right down the center of both of these histograms. But there's more to a distribution than just finding its measure of center. We can also talk about its measures of spread. So what do we mean when we talk about measures of spread of the data? So any set of data has variation in the data. And in some data sets, the data values are concentrated closely near the mean, okay, near the center, or in other data sets, the data values are more widely spread out from the mean. So you can see a histogram of sample one, we can see that the data appears to be more closely concentrated to the mean, whereas the histogram of sample two, the data seems to be spread out more uh, from the mean. So these two histograms, okay, these are the two data sets that we've got for sample one and sample two. Notice that they both have 15 datums in the data set, but even though they have the same number of datums, their shapes of their histograms are quite different. So the datums in sample one are distributed closer to the sample mean, which is 15. And when you've got data which is closer to the sample mean, it'll have what's called a smaller standard deviation. And what we mean by a small standard deviation is that the distribution is narrow about the mean. Now flip over here to histogram 2. The datums in sample 2 are distributed further from the sample mean. Okay, so it's got a wider variation. And so sample 2 has a larger standard deviation. A large standard deviation equals a wide distribution of the data about the mean. So the standard deviation is going to be a number, it's going to be a value. And if that value of the standard deviation is larger, then there's going to be more variation in your distribution. It'll be wider. If the standard deviation of a distribution is small, then the distribution is going to be narrow. And the values will be concentrated closer to the mean. And so, here's a note that the vertical height, here frequency of both sample one and sample two, the height of the distribution does not define the standard deviation. Only the horizontal widths of both of these samples determine the standard deviation. Okay, so what exactly is the standard deviation in a little more detail? Well, the standard deviation can be written in two different variables. Because often in statistics, we're talking about two different groupings of data. We're talking about a population, and then we're talking about a subset of a population, which is a much smaller sample. That's a representative sample of the population the sample was taken from. And so we need variables for standard deviation, but to differentiate between the standard deviation of a population and the standard deviation of a sample. So we use the Greek letter sigma to indicate the standard deviation of a population and just a lowercase s to represent the sample standard deviation. And this is very similar to what we did with a mean, right? We used x bar to stand for a sample mean, and we used the Greek letter mu to represent a population mean. Um, in the absence of a population mean, in the absence of a population standard deviation, we can use a sample standard deviation as an estimate. Both S and sigma represent the overall amount of variation in a data set. And the value of the standard deviation determines whether a particular data value is close to or far from the mean. Standard deviation will always be a positive number or zero. The standard deviation will be small when the data is concentrated near the mean. The standard deviation will be larger when the data is dispersed away from the mean. And outliers can have a strong effect on the standard deviation. Now, down below are the two equations that are used to calculate the sample standard deviation and the population standard deviation. And you'll see they're very much identical. It's just that when we're talking about a sample standard deviation, we're using a sample mean. And when we're talking about a population standard deviation, we're using a population mean. And instead of taking the sample size and subtracting by 1 here, we're just using the population size. Now the graphing calculator will do this calculation for you. But what you can see it's happening here is that you calculate the sample mean from a data set, and you find the difference between every datum in a data set and the mean of that sample. So you find the difference between each one, and you square those values. You take all those differences squared and you add them up. You divide by the sample size minus 1, and then you take the square root of that, and that gives you the sample standard deviation. Mean as a measure of center and standard deviation are often used together. So if we're referring to samples, you'll see things like the sample mean plus 1 standard deviation, the sample mean plus 2 standard deviations, the sample mean plus 3 standard deviations. And then we could also write the sample mean minus 1 standard deviation, the sample mean minus 2 standard deviations, and the mean minus 3 standard deviations. So if we go back to this earlier picture that we had, right, the center of this was the sample mean. And to kind of talk about its width, we would take the sample mean and add 1 standard deviation. And then we would add another standard deviation. And that might be a value like this. And then we'll take the mean and add 3 standard deviations. And that might be a value right there. So we often talk about the mean as the center point and then go out a certain number of standard deviations away from the mean. And we can go in the positive sense, and we can also go in a negative sense by successively subtracting standard deviations from the mean. And we use this, also as a point of reference to go above and to go below this measure of center, to below the mean. All right. Now how do you find this standard deviation? if you're given a data set. So here's a quick example. So I've already kind of given you the data set for sample 1, and here's the data set for sample 2. The first thing you want to do is you want to enter these data sets into your calculator. So to do so, what you want to do is you want to go into the list editor with the Texas Instruments calculator. So hit the Stat button, go to Edit menu, and select Edit. And you see I've already put the values in. List 1 are the unique values in sample 1. And then list 2 is the frequency of each unique value. So you can see 13 occurs once, 14 occurs 4 times. So 13 occurred once and 14 occurred 4 times, right? And then I also went ahead and I put the values for sample 2 into list 3. And I put the frequency of each unique value in sample 2 here in list 4. With the NumWorks calculator, what you do is you go into the Statistics app, and here under the Data tab, under column V1, I put the unique value in data set 1 or in sample 1, and then this column N1 is the frequency. So 13 occurred once, 14 appeared 4 times, and so on. And then I went over to the right and I put the values for sample 2, the unique datums in sample 2 in column V2. And then in column N2, I put the frequency of each unique datum in sample 2. All right, so let's get the standard deviation of sample 1, and then we'll get the standard deviation of sample 2. So let me show first how to do it on the NumWorks calculator, because I think it's maybe a little easier. So you'll notice that the NumWorks calculator has 3 tabs across the top. We are currently in the Data tab. So what we want to do is we want to move our selection up to these tabs and go over to the Stats tab and select OK. So I'm going to move the up arrow. Now I'm in the tabs. I'm going to move it to the right over to Stats and click OK. And I want to scroll down until I get to Sample Standard Deviation. Now don't confuse standard deviation with sample standard deviation. Notice that this one is listed as sigma. So this is a population standard deviation. And then the sample standard deviation has the variable s, just like in your lecture notes. And so what we want is the sample standard deviation. And if we scroll over to the right, all right, you can see the standard deviation for sample 1 is 1.07. And the sample standard deviation for sample 2 is 2.8. So sample 2's standard deviation is greater. Sample 1 is smaller. Keep that in mind, because when we come back, the standard deviation of sample 1 was smaller, so it's narrower. The standard deviation of sample 2 was larger, so it's wider. All right, now to calculate this with the Texas Instruments calculator, the way that I've done it, is you want to hit the Stat button, go to the Calc menu, and choose one variable stats. Okay, so we're going to be looking at the unique values of sample 1, and then the frequency list is in list 2, and I'm going to hit Calculate. And this value here, which is Sx, that's the sample standard deviation. And so we've got 1.07. That's the same value that I had with the NumWorks calculator. And we can do the same thing with sample 2. So let me quit out of that. And let's just revisit the list editor. So sample 2 has the unique values in list 3 and the frequency in list 4. So I'll hit stat, go to calc, one variable stats. Okay, now the list of values for sample 2, that's in list 3. So I hit the second button and the number 3, and it printed an L3 there. Then my list of frequencies was an L4. So I'm going to hit second, L4. Go down to calculate. Oops, I have to hit enter. Then calculate. And you can see my sample standard deviation is 2.83, roughly. So that's what these two screenshots are down here. One variable stats for each sample. So notice that this sample standard deviation is smaller than that of sample 2. And because sample 1's standard deviation is smaller, this distribution is narrower. And because the standard deviation of sample 2 is larger, it is broader, it is wider. Okay, down below here is where I've got the screenshot for the NumWorks calculator. And here's the sample standard deviation of 1.07. And you scroll over, you can see both side by side here at the same time. All right. So, that's a brief description of standard deviation, how you can enter the values into your calculator and use the calculator to calculate the standard deviation of any data set that you put in there with both Texas Instruments and NumWorks. Okay, let me know if you have any questions.